All I want to do with these is go through a few of the definitions. There's three terms. We're just going to do 3 slides here. And I'll introduce the terms or the figures that we're going to talk more about in the next section. So the first thing I'm going to do with each of these, I refer to them as dissected circles. They're just portions of a circle or portions that are cut from an actual circle. And so the first one that I'm going to talk about, we've already dealt with, and that's a semicircle. By definition, a semicircle is the figure enclosed by a diameter and the circumference cut off by it. Okay, so here if you took a circle and we drew in 1 diameter and we included the curved portion that's cut off by that diameter, the part of that circumference, that is our semicircle. And as far as the naming conventions go, when you name a semicircle, you can name it as an arc. So we can call this arc ACB or arc BCA. Again, remember when you name it as an arc, you do have to include 3 points. The 2 endpoints of the diameter are the first and last, and then some other point that's contained on the arc has to be between those. Or you might see it just spelled out, semicircle, ACB, or BCA. Okay, so that's the naming conventions for that figure. And then this one has 2 special properties to talk about. No. Because, again, in this particular case, it's possible that there would be another half, and so you wouldn't know which half that's being identified. All right, as far as the perimeter the special properties are concerned, the perimeter of a semicircle you can identify. Is the perimeter of a semicircle going to be half that of a corresponding circle with the same radius or diameter? No, because that would be the curved portion of it, right? But then we also have to add in this straight segment, this diameter. So a perimeter is going to be made up of both the curved portion, which is half of a circumference, plus the straight portion, which is a diameter. And now, if you think about the ways that we can express circumference, we can find 2 specific equations for the perimeter. Okay, one is if we express it in terms of the diameter. Okay, so one way to express the perimeter is 1/2 of the circumference of a circle in terms of diameter is d pi plus d. So here's one way that you could express the perimeter of a semicircle. And then the other way would be to express it in terms of a radius. So if you were thinking in terms of a radius, the circumference of a circle in terms of radius is 2 pi r, and the diameter in terms of a radius is 2r. And so you could simplify this, the half and the 2 cancel. So the other way that you can express the equation for the perimeter is pi r plus 2r. So either of those will give you the total perimeter of a semicircle. It all depends whether you're involving a measurement of its radius or a measurement of its diameter. Okay, the other special property involving a semicircle has to do with an angle that's inscribed within the semicircle. In order for an angle to be inscribed in a semicircle, what that means is its vertex lies on the curved portion of the semicircle. Okay, so those are the properties of an angle inscribed in a semicircle. And if you imagine, you guys saw this in your quiz for 4142. And if you imagine that you have these angles, and you extend the remaining portion of the circle from a semicircle. You have an inscribed angle of the circle. Since it intersects the endpoints of the diameter, what is the arc measure that is intercepted by these inscribed angles? It's a semicircle itself, so it's an arc measure of 180, which means the inscribed angle is 1/2 of the intercepted arc. So what's 1/2 of 80? 90 degrees. And so you can see here that any angle inscribed in a semicircle is always going to equal 90 degrees. It's always going to be a right angle.